So we've already gone through the 4 steps to find a network addresses, broadcast address, and available addresses for a network based on an IP and mask. Let's take some quick shortcuts here. We know that there are 32 possible bits for every octet. That means 32 possible binary ones, which would equal 255. With that knowledge, we could do 32 possible bits minus the 24 bits of our mask to get a difference of 8. That means there are 8 bits that are open, right? If we raise 2 to the power of 8, since each of these 8 bits is binary, it could be one or on or off, 1 or 0, we get 256, right? Because 8 possible, that could be 1 or 0, which is why it's 2 to the power of 8. It's 256 open addresses. We know that 0 through 255 is 256 numbers. If we include 0, that means the highest amount of numbers an octet can have is 256. If we divide 256 possible numbers for an octet by the 256 open addresses that we just discovered, we know that there is one network, right? So 256 divided by 256, one network. And then you subtract the network and broadcast addresses because those cannot be assigned. And then you have 254 available addresses. So we found that all out just using this notation here, the /24, just using a mask. We got all that information. So that was a simple network, right? What about what I call interesting networks, networks that aren't as simple, like the last example we had on the other slide? In this case, we start with the same IP address, but now the mask is /25, which is not as clean cut as 24, right? Okay. Step 1 is the same. We need to write out the mask in decimal notation. Step 2 is to find the interesting octet and a magic number, which is a number that will help us with a shortcut that we're going to use. So the interesting octet is any mask octet that is not 0 or 255, right? So 255, 255, 128. So this is not a 0 and it's not 255. So in this case, we get the interesting mask octet number 128, right? So we know that the most amount of numbers possible for an octet is 256, right? So we're going to subtract our 128 from 256, and that gives us our magical number, which just so happens to be, in this case, 128, right? 256 minus 128 is 128, which is our magic number. So this magic number, using this magic number, the network is subnetted into multiples of the magic number up to the most amount of numbers, which is 256, right? So multiples of 128. So start with 0. Multiple 128 is 128. Another multiple of 128. So 128 times 2 here is 256. So it's the highest you can go because, right, 256 is the highest possible that you can have. So because this is 256 and we know this is the highest possible you can have, that means this can't be a network because it would be a network of nothing, right? You can't have anything. So there is 2 subnets because these 2 can have IPs that you can divvy out. This one cannot. This is too much. This is the whole thing. It wouldn't work. Next, we'll look for the network address of the subnet our IP is in. First, we're going to carry down the octets of our IP that go up against 255 here, right? Then for our last octet, which we know is 20, we need to find where that number is within the multiples of 128 that we discussed here. So 20 is between 0 and 128, right? So that means our subnet network address for our IP address is 192.168.1.0, right? Because 20 is in between 0 and 128. So you're going to go with 0 because it's in between. Because between here and here is one subnet. Between here and here is the second subnet. So now that we have the network address, we need the broadcast. As we know, our last octet is the only one that can change. It's the only one in this case. So we know it can only go up to the next multiple of our magic number, which is 128, which would be the next network address. So that means the next network address is 192.168.1.28, leaving 192.168.1.127 as the last available IP in our subnet, making this now the broadcast address for this subnet. For the subnet 192.168.1.0/25, the broadcast address is 192.168.1.127, because 192.168.1.128 is the next network. So that has to be assigned to that network address. Finally, let's find the available addresses for our subnet. So we know now that it's 192.168.1.0 all the way up into 192.168.1.127, since we include 192.168.1.0 in the count. So if we subtract the network address and broadcast address, we get 126 available addresses. So remember that shortcut we had using only the subnet mask? Well, we can use that here too. So we got /25, 32 possible bits, minus the 25 we just used, leaves us with 7. So 7 has the option of being on or off. So we do 2 raised to the 7, which gives us 128. We know there's 256 possible bits, right? Because we count 0. And so we divide that by our 128 open addresses, which gives us 2, meaning there's 2 subnetworks. So then 128 minus 1 network minus 1 broadcast, because 126 available addresses in both those networks. So you won't have to memorize this, but it's good to know and play around with so you understand the concepts that these online subnet calculators use to get you answers.